Good day everyone! Today we are going to be discussing about the weight-volume relationships. I am Engineer Ursel Verdadero.
In the previous chapter, the physical processes by which soils are formed, along with the soil particle size limits, were discussed. In natural occurrence, soils are a three-phase system consisting of soil solids, water, and air. The water and air spaces are considered as the void spaces. It is important to know the void volume in a given soil and its moisture content to determine its unit weight in the field. This chapter describes the weight-volume relationships for soils, that is, the relationship between unit weight, void ratio, porosity, moisture content, and the specific gravity of soil solids. Now, let us consider this figure. For us to understand the weight-volume relationship, let us consider this as the weight of air, weight of water, and weight of soil. And on the left side, the volume of air, volume of water, and volume of soil, in which the volume of air and volume of water is considered as the void spaces, therefore it is equal to the volume of the voids. Now, we can see that the weight total is equal to the summation of weight of air less weight of water and weight of soil. But the weight of air is negligible, approximately equal to 0. Therefore, the total weight is equal to the weight of water plus weight of soil. And the total volume, based on the figure, is equal to the volume of air plus volume of water plus volume of soil. But the volume of the void is equal to the volume of air plus volume of water. Therefore, the volume total is equal to the volume of the voids plus the volume of the soil. The volume relationship commonly used for the three phases in a soil elements are the void ratio, porosity, and degree of saturation. The void ratio, E, is defined as the ratio of the volume of the voids to the volume of the solids. The porosity, N, is equal to the ratio of the volume of the voids to the total volume, or VV over V. And the third is the degree of saturation, or S, is defined as the ratio of the volume of the water to the volume of the soil times 100% to express it in percentage. The common weight relationships are moisture content and unit weight. Moisture content are also referred to as water content and is defined as the ratio of the weight of water to the weight of solids. And the second is the unit weight, which is equal to the weight of soil per unit volume.
Void ratio E is equal to volume of the voids over volume of soil. Porosity N is equal to volume of the voids over volume total. From the formula that volume total is equal to volume of air plus volume of water plus volume of soil, where volume total is equal to volume of the voids, since volume of air plus volume of water is equal to the volume of the voids plus volume of soil. So, therefore, volume of soil is equal to volume total minus volume of the voids. From E is equal to volume of the voids over volume of the soil, where volume of soil is equal to volume total minus volume of the voids. Let us multiply this equation by the ratio volume total over volume total, which, as you can see, this is also equal to just a value of 1. Therefore, volume of the voids over volume total all over volume total over volume total minus volume of voids over volume total. So this is n, this is n, and this is 1. Therefore, E is equal to n over 1 minus n. From the equation that the porosity n is equal to the volume of the void over volume total, but volume total is equal to the volume of the void plus the volume of the soil. If we multiply this equation by volume of soil over volume of soil, which is just equal to the value of 1, then we will get n is equal to volume of the voids over volume of soil all over volume of the voids over volume of soil plus volume of soil over volume of soil, in which the void ratio is equal to volume of voids over volume of soil. This will be equal to void ratio E, and this is also equal to void ratio E, and Vs over Vs equal to 1. Therefore, porosity n is equal to void ratio E over E plus 1.
To solve for the relationship formulas involving a dry unit weight, moisture content, degree of saturation, specific gravity, porosity n, first let us consider our soil element that the volume of soil is equal to 1 unit. To derive other formulas relating to the volume, let us consider the volume of soil equal to 1. Now, from the formula of the void ratio, which is E is equal to volume of void over 1, if we consider the volume of soil equal to 1, therefore, the void ratio E is equal to the volume of the voids, as you can see here in our figure. The total volume will now be equal to 1 plus E, or the void ratio. To solve for the volume of the voids, let us recall that the void ratio E is equal to volume of the voids over volume of the soil, in which the volume of the soil was assumed to be equal to 1. Therefore, volume of the voids is equal to the void ratio E. To solve for the volume total, based on the figure, the volume total is equal to volume of the voids plus volume of the soil. Since volume of soil was considered equal to 1 and volume of the voids was solved and was find out that it was equal to 0, therefore, total volume V is equal to 1 plus void ratio E. To solve for the weight of soil, let us recall that from the formula of the specific gravity of soil is equal to unit weight of soil over unit weight of water, and also unit weight of soil is equal to weight of soil over volume of soil. Then, specific gravity of soil multiplied to unit weight of water will now be equal to weight of soil over volume of soil. So, since volume of soil was considered equal to 1, therefore, weight of soil is equal to specific gravity multiplied to unit weight of water. To solve for the weight of water, let us recall that the moisture content is equal to weight of water over weight of soil. Solving for
the weight of water is equal to moisture content multiplied to weight of soil. But since the weight of soil is equal to specific gravity times unit weight of water, we will get weight of water equal to moisture content multiplied to specific gravity of soil times unit weight of water. To solve for the volume of water, again from the formula that the unit weight of water is equal to weight of water over volume of water. Solving for the volume of water, we will get weight of water over unit weight of the water. But since we solved the corresponding value for the weight of water, which is equal to moisture content multiplied to specific gravity times unit weight of water, which is the weight of water, all over unit weight of water. So, this is equal to 1. We will get the value of volume of water equal to moisture content multiplied to specific gravity of the soil. So, these are the values for our derivation. Now, let's proceed to the derivation of other relationship formulas for the weight volume.
The total volume V will now be equal to 1 plus E, as you can see here in our figure. The volume of water is equal to moisture content times multiplied to the specific gravity. Considering the volume of soil is equal to 1, the degree of saturation is also equal to 1, which means it is in a saturated condition. Volume of soil is equal to 1. Since it is in a saturated condition, the volume of the voids is equal to the volume of the water, since all the void spaces are occupied by the water. And it is equal to void ratio E. Therefore, the volume total is now equal to 1 plus void ratio E. Now, let us look at the other formulas relating to the weight. If we consider the volume of soil equal to 1, we will get weight of soil is equal to specific gravity times the multiplied by the unit weight of water. Weight of water is equal to moisture content multiplied to specific gravity of water multiplied to unit weight of water. Considering volume of soil is equal to 1 and S is equal to 1, which is in a saturated condition. Take note that if the degree of saturation is equal to 1 or 100%, the volume of the water occupied all the void spaces. We will get weight of soil is equal to specific gravity times unit weight of water. Weight of water is equal to void ratio E times unit weight of the water.
To solve for the moist unit weight, wet unit weight, or total unit weight, they are all just the same. Moist unit weight is the unit weight of soil considering the presence of water. So, let us recall that the unit weight is equal to weight over volume. So, for moist unit weight, the weight will be equal to weight of the soil plus the weight of the water, and the volume is equal to the volume of the voids plus volume of the soil. So from our derivation a while ago, we can now say that the weight of soil is equal to specific gravity G sub S multiplied to unit weight of water plus the weight of water is equal to moisture content multiplied to specific gravity times unit weight of water all over the total volume, which is equal to 1 plus the void ratio E. And if we simplify this formula, we will get that the moist unit weight is equal to specific gravity times unit weight of water quantity multiplied to quantity 1 plus void ratio E all over 1 specific gravity times unit weight of water multiplied to the quantity of 1 plus moisture content all over 1 plus E. Now, if we solve for the dry unit weight, so if we are talking about a dry unit weight, it means that the soil is under a dry state without the presence of water. Therefore, from the formula that the unit weight is equal to weight over volume, the weight we are going to consider is only now the weight of the soil over the total volume without the presence of the water. So let's say that this symbol is equal to the dry unit weight, and since the weight of soil is equal to specific gravity times unit weight of water, and the volume is equal to 1 plus E. This now is our formula for the dry unit weight. The dry unit weight is equal to specific gravity multiplied to unit weight of water all over the 1 plus the void ratio E. Now let us solve for the formula relating to the degree of saturation. Remember that the degree of saturation is defined as the volume of water over volume of the voids. But since the volume of water is equal to moisture content times specific gravity, and the volume of the voids is equal to the volume of the void is equal to the void ratio E. We will get that the degree of saturation is equal to moisture content multiplied to specific gravity all over void ratio E. Now, let us solve for the saturated unit weight. When we say saturated, the degree of saturation is 100%. So, to make the degree of saturation 100%, from the formula that the degree of saturation is equal to volume of water over volume of voids, therefore, the volume of water is equal to the volume of the voids. The formula for the unit weight is equal to weight over volume. Since we are computing for the saturated unit weight, let us use this symbol to represent the saturated unit weight. So, weight is equal to weight of the soil plus the weight of the water, in which the weight of the water occupying all the void spaces because it is in its saturated state over the total volume. So, weight of soil from our previous derivation is equal to specific gravity times unit weight of water, and the total volume is equal to 1 plus void ratio E. Now, the only thing that will change is the weight of the water because now it is in saturated unit weight, therefore it is much heavier because the water now is occupying all the void spaces. As you can see here in this relationship, that the volume of the water is equal to the volume of the voids. So, to derive the formula for the weight of the water, let us use this formula that the unit weight of water is equal to weight of water over the volume of water, in which the volume of water now is equal to the volume of the voids. But in our figure, the volume of the voids is equal to the void ratio E. Therefore, this volume of water is equal to the volume of the voids, which is also equal to the void ratio E. So, to compute for the weight of the water, let us compute for the weight of the water. It is now equal to unit weight of water multiplied to void ratio E. So, in saturated condition, let us use this value. So, substitute this value to here. So, we will get saturated unit weight is equal to specific gravity multiplied to unit weight of water plus unit weight of water multiplied to void ratio E all over 1 plus E. Or if we simplify this formula, we will get saturated unit weight is equal to, factor out the unit weight of water multiplied to the quantity specific gravity plus void ratio E all over 1 plus void ratio E. So these are our formula. And the wet density of the soil will just be equal to the formula rho is equal to quantity 1 plus moisture content multiplied to specific gravity times density of water all over 1 plus void ratio E. Now, for the dry density, the formula will be rho D, rho sub D is equal to specific gravity multiplied to density of water all over 1 plus E, or the void ratio E. And for the saturated density, the formula will be rho sat is equal to density of water multiplied to specific gravity plus E all over 1 plus E, or the void ratio E. Now, these are our formula for the relationship among unit weight, void ratio, moisture content, specific gravity, and degree of saturation under the consideration that the volume of soil is equal to 1, and also under the consideration of that the degree of saturation is less than 1 and also equal to 1. Now, we are going to derive the relationship formulas of unit weight, porosity, and moisture content under the consideration now that the total volume is equal to 1. Now, let us solve for the volume of the voids. To solve for the volume of the voids, recall that the porosity N is equal to volume of the voids over the volume total, in which volume total is assumed to be equal to 1. Therefore, the volume of the void is equal to porosity N. Now, to solve for the volume of the soil, if we look at our figure, the volume total is equal to volume of the voids plus volume of the soil, in which the volume total is equal to 1 and the volume of the voids equal to porosity N. The volume of the soil is equal to 1 minus porosity N. Now let us solve for the weight of soil. Recall that the unit weight of soil is equal to weight of soil over volume of soil. So, weight of soil is equal to unit weight of soil times volume of soil. In which unit weight of soil is equal to specific gravity multiplied to unit weight of water, and the volume of soil is equal to 1 minus N. Therefore, weight of soil is equal to specific gravity multiplied to unit weight of water times the quantity 1 minus N. Now, if we consider that the soil is under saturated condition and also the volume total is equal to 1, under saturated condition, S is equal to 1 or 100%. Now, to solve for the volume of the voids, let us recall that the porosity N is equal to volume of the voids over volume total. Since volume total is equal to 1, volume of the voids is equal to porosity N. But since this is in a saturated condition, under saturated condition, volume of the void will now be equal to volume of water. From the formula that S is equal to volume of water over volume of the voids is equal to 1. So, the formula for the volume of the voids is equal to volume of water is equal to porosity N. Now, to solve for the weight of the water, let us recall that the unit weight of water is equal to weight of water over volume of water. But since the volume of water under saturated condition is equal to porosity N, we will get a value of weight of water is equal to porosity N multiplied to unit weight of water. Now let us solve for the moist unit weight under the consideration of the volume total is equal to 1. So for the moist unit weight is equal to weight over volume. So since this is a moist unit weight is equal to weight of water plus weight of soil over total volume. From the equation, we can say that the weight of water is equal to moisture content times specific gravity times unit weight of water multiplied to the quantity 1 minus N, plus the weight of soil is equal to specific gravity multiplied to unit weight of water multiplied to 1 minus N, all over total volume, which is equal to 1. Therefore, we can say this is as is the value of the moist unit weight. And if we simplify this, we will get moist unit weight is equal to specific gravity times unit weight of water multiplied to 1 minus n multiplied to 1 plus moisture content. Now let us solve for the dry unit weight. Dry unit weight is equal to gamma dry is equal to weight of soil over total volume. Dry unit weight will now be equal to, since the weight of soil is equal to specific gravity times unit weight of water multiplied to 1 minus n, all over total volume, which is equal to the value of 1. Therefore, this will be our formula for the dry unit weight. Now let us solve for the saturated unit weight. Under the saturated condition, S is equal to 1 or 100%. So, Y sat is equal to weight of soil plus weight of water all over volume total. Since under saturated condition, the weight of water is equal to porosity N multiplied to unit weight of water, we will get saturated unit weight is equal to the weight of soil is equal to specific gravity multiplied to unit weight of water times the quantity 1 minus n plus the weight of water, which is equal to porosity N multiplied to unit weight of water, all over volume total is equal to 1. And if we simplify this equation, we will get saturated unit weight is equal to unit weight of water multiplied to n plus specific gravity multiplied to quantity 1 minus n. Now, to solve the relationship of moisture content, porosity, and specific gravity, let us recall that the moisture content is equal to weight of water over weight of soil, and weight of water under saturated condition is equal to n times unit weight of water all over the weight of soil is equal to specific gravity multiplied to unit weight of water times the quantity 1 minus n. So if we simplify this, we will get n all over specific gravity times the quantity 1 minus n. This is equal to 1. These are our formula derived using the relationship formulas among unit weight, porosity, and moisture content under the consideration that the volume is equal to 1 under saturated and non-saturated conditions. Now, let us try to solve example problems relating to the weight-volume relationship problems. Let us solve the following problem. Sample problem number 1. A moist soil has these values. V, or the volume, is equal to 7.08 times 10 raised to negative 3 cubic meter. M, or the mass, is equal to 13.95 kilogram. Moisture content is equal to 9.8% and specific gravity is equal to 2.66. Determine the following. Letter A, density. Letter B, dry density. C, void ratio. D, porosity. E, degree of saturation. And F, the volume occupied by water. Solution. For letter A, we are to determine the density. If we are to talk about the density of a soil, it means it is also the wet density or the total density of the soil. From the formula of the density is equal to mass over volume. in which the mass is equal to 13.95 kilogram all over the volume total is equal to 7.08 times 10 raised to negative 3 cubic meter. Therefore, our density is now equal to 1970.3 kilogram per cubic meter. For letter B, we are to determine the dry density. From the formula that the density is equal to dry density multiplied to the quantity 1 plus moisture content, we can derive that the dry density is equal to the moist density all over 1 plus moisture content. So, if we substitute those values, dry density is equal to 1970.3 kilogram per cubic meter all over 1 plus the moisture content is said to be 9.8%. So therefore it is 9.8% over 100%. If we solve for the dry density, we will get 1794.4 kilogram per cubic meter. If we look up the value of the moist density and the dry density, we can say that the moist density is greater than the dry density because in moist density there is a presence of water. Unlike in dry density, the weight of the water is not considered, only the weight of the soil. Now we are to determine the void ratio E. From the formula that the dry density is equal to specific gravity multiplied to density of water all over 1 plus the void ratio E. If we arrange our formula, we should be able to get that the void ratio E is equal to the specific gravity multiplied to density of water all over the dry density minus 1. If we substitute the values, void ratio E is equal to the specific gravity is 2.66. We all know that the density of water is 1000 kilogram per cubic meter. And the dry density was solved a while ago, which is equal to 1794.4 kilogram per cubic meter minus 1. Therefore, void ratio E is equal to 0.48. Next, for letter D, we are to determine the porosity N. To solve for the porosity N, we will use the relationship of the porosity and void ratio, which is N is equal to void ratio E all over 1 plus void ratio E. N now will be equal to 0.48 over 1 plus 0.48. Therefore, if we solve the value of N, we will get N, or the porosity N, is equal to 0.324. Next, for letter E, we are to determine the degree of saturation. We will use the relationship formula of degree of saturation, moisture content, specific gravity, and void ratio E. So, from our previous derivation, we got that degree of saturation S is equal to moisture content multiplied to specific gravity over the void ratio E. Now, the degree of saturation, if we substitute the values, the moisture content is equal to 9.8% or 0.098 multiplied to the specific gravity is 2.66 all over the void ratio E is equal to 0.48 multiplied to 100 to get the value in percentage. Therefore, S is equal to 54.3%. For the last requirement, we are to determine the volume occupied by the water. From the formula that the density of water is equal to mass of water over volume of water. Volume of water is equal to mass of water over density of water. To solve for the mass of water, the mass total is equal to mass of soil plus mass of water. We know that the mass total is equal to 13.95 kg. So we are to find the mass of soil. The dry density is given. We can use that formula that the dry density is equal to mass of soil over volume total. So mass of soil is equal now to dry density, which is 1794.4 kilogram per cubic meter multiplied to the volume V, which is equal to 7.08 times 10 raised to negative 3 cubic meter. So therefore, mass of soil is equal to, now we got the mass of soil is equal to 12.7 kilogram. Now we can now solve for the mass of water, which is mass of water is equal to mass total is equal to 13.95 kilogram minus the mass of soil is 12.7 kilogram. Mass of water is now equal to 1.25 kilogram. Going back to the equation, now we can solve for the volume occupied by the water, which is volume of water is equal to mass of water over density of water, in which mass of water is equal to 1.25 kilogram over density of water is 1000 kilogram per cubic meter. Therefore, volume of water is equal to 0.00125 cubic meter. So these are the solution for our problem number 1. Now, in our example number 2, in the natural state, a moist soil has a volume of 0.3 cubic meter, as you can see in our figure, and weighs 5,500 Newton. The oven dry weight of soil is 4,911 Newton. If the specific gravity is equal to 2.74, calculate the moisture content, moist unit weight, dry unit weight, void ratio, porosity, and degree of saturation. First, let us compute for the moisture content. As you can see here in our figure, the weight total of the soil is 5,500 Newton. And the oven dry weight of the soil, it means it is the weight of soil because it don't have the presence of water in it, is equal to 4,911 here in our figure. Therefore, the weight of water is equal to weight total minus weight of soil. So we can say that the weight of water is equal to 589 Newton. Moisture content is equal to weight of water over weight of soil. So, weight of water is equal, moisture content now is equal to, weight of water is 589 Newton over weight of soil 4,911 Newton. Therefore, the moisture content is equal to 0.12, or moisture content is equal to 12.0%. Now, to solve for the moist unit weight, the formula moist unit weight is equal to weight total over volume total. Weight total is equal to 5,500 Newton, and the volume total is equal to 0.3 cubic meter. Therefore, the moist unit weight is equal to 18.33 kilonewton per cubic meter. Now, let us solve for the dry unit weight. The formula for the dry unit weight that we can use is gamma dry is equal to moist unit weight over 1 plus moisture content. So, if we substitute the value, we will get dry is equal to 18.33 kilonewton per cubic meter over the moisture content 1 plus 0.12. So, the dry unit weight now is equal to 16.37 kilonewton per cubic meter. Now, to solve for the void ratio E, we recall that the formula for the void ratio is equal to volume of the voids over volume of the soil. The formula for the volume of soil is equal to weight of soil over specific gravity multiplied to unit weight of water. Volume of soil now is equal to weight of soil. So, weight of soil is 4911 Newton over the specific gravity, which is equal to 2.74, and the unit weight of water is 9.81 kilonewton per cubic meter. Solving for the volume of soil, we will get the volume of soil equal to 0.1827 cubic meter. To solve for the volume of the voids, let us recall that the volume total is equal to volume of the voids plus volume of the soil. The total volume is equal to 0.3 cubic meter, and the volume of the soil is equal to 0.1827 cubic meter. So, solving for the volume of the voids, we will get volume of the void equal to 0.1173 cubic meter. Now, going back to the void ratio, we can now solve the void ratio. So, the void ratio E is equal to volume of the voids 0.1173 cubic meter over the volume of the soil, which is equal to 0.1827 cubic meter. So now the void ratio is equal to 0.64. Solving for the porosity, we will use relationship formula for the void ratio and porosity. Porosity N is equal to the void ratio E all over 1 plus void ratio E. So, solving for it, substitute the values. Void ratio E from our computation is 0.64 4 over 1 plus void ratio E 0.64. Now, we solve that the porosity N is equal to 0.39. To solve for value for the degree of saturation, let us recall that the degree of saturation is equal to the volume of water over the volume of the voids. So we have the value for the volume of the voids, which is equal to 0.1173. To solve for the volume of water is equal to weight of water over unit weight of water. So the weight of water is 589 newtons and the unit weight of water is 9.81 kilonewton per cubic meter. Therefore, if we solve for the volume of water, we will get weight of water to 0.589 kilonewton over unit weight of water to 9.81 kilonewton per cubic meter. So the volume of water is equal to 0.06 cubic meter. The volume of water now is equal to 0.06 cubic meter. The degree of saturation. The degree of saturation is equal to the volume of water, which is equal to 0.06 cubic meter over volume of the voids is equal to 0.1173 cubic meter multiplied to 100% to get the value in percentage. So now the degree of saturation is equal to 51.2%. So this is our solution for problem number 2.
So that's it for our discussion in weight-volume relationship. Don't forget to hit the like button and the subscribe button for more updates about the geotechnical engineering lectures. And for your questions, you can comment down below your questions. Stay tuned for more updates about the geotechnical engineering lectures and other civil engineering lectures. Thank you very much. See you again.